Throughout history, humanity has sought to understand the nature of existence. Have you ever wondered what makes a person truly unique? For centuries, philosophers and spiritual leaders have spoken about the soul. The soul is often described as the very essence of being. It is considered the part that feels. It is the part that loves. It is the part that experiences the world. Many believe the soul is separate from the physical body. Some think it may even continue to exist after death. But what does science have to say about this? Can evidence for something as mysterious and personal as the soul be found using microscopes and equations? This question has long been considered outside the realm of scientific inquiry, a topic best left to faith and philosophy, but that is starting to change as researchers now look for answers in the most unexpected of places. Notably, the brilliant Sir Roger Penrose and his collaborators have embarked on a journey to tackle this very question. Roger Penrose is a Nobel Prize-winning physicist from the University of Oxford. He is renowned for groundbreaking work on black holes. Penrose explores the very nature of reality itself. Stuart Hameroff is an anesthesiologist and professor at the University of Arizona. His career has focused on studying consciousness from a medical perspective. Hameroff has observed firsthand how consciousness can be turned off and on with anesthetic gases. These experiences led to questions about the fundamental nature of consciousness. Together, Penrose and Hameroff developed a theory that they believe connects the tangible world of the brain to the profound mystery of consciousness, and perhaps even the soul. This theory is called Orchestrated Objective Reduction, or ORCH for short. It may sound complicated, but the basic idea is quite straightforward. So what exactly is this thing called consciousness? It is the feeling of being alive. It is the redness of a rose. It is the taste of chocolate. It is the warmth of the sun on your skin. It is the sound of a favorite song. It is thoughts, memories, feelings, and the sense of self. Scientists call these subjective experiences qualia. A brain scan can reveal which parts are active when a person sees the color red, but the experience of redness itself cannot be found in those scans. This is what philosophers call the hard problem of consciousness. How does the wet, biological matter of the brain, the 3 pounds of tissue within the human skull, give rise to the rich, non-physical world of inner experience? For many years, the prevailing view in neuroscience has been that consciousness is an emergent property. According to this idea, when enough neurons are connected in a complex network, consciousness appears as a result. The brain is often compared to a sophisticated biological computer, with neurons functioning like transistors and their firing patterns resembling computer code. In this framework, feelings and awareness are considered the result of complex calculations. However, this explanation is often regarded as incomplete by many in the scientific community. A computer can process information about the color red, but it does not actually experience redness. This distinction is widely recognized. There appears to be something missing from this picture. Here, the mystery of consciousness deepens. Consider the phenomenon of anesthesia. Specific gas molecules can be administered that selectively erase consciousness while leaving other brain functions, such as breathing, intact. When most people think of quantum physics, they imagine strange phenomena occurring in distant stars or within giant particle colliders. Stories abound of particles existing in 2 places at once or being instantly connected across vast distances. This is the quantum world where the rules differ greatly from those of everyday experience. For a long time, scientists believed that such quantum behavior could only occur in extremely cold, isolated, and simple systems. The brain, by contrast, is warm, wet, and incredibly complex. As a result, the possibility of quantum processes occurring within the brain was long dismissed by most as impossible. What if structures within brain cells were perfectly designed to protect and support delicate quantum processes? This is where the orchestrated objective reduction theory begins to take shape. Inside every neuron lies an intricate internal scaffolding known as the cytoskeleton. The key components of this cytoskeleton are tiny hollow cylinders called microtubules. Microtubules are proposed to be more than just structural supports. They may function as quantum computers within the brain. Microtubules are composed of protein subunits called tubulin. Tubulin can exist in different shapes. This ability to switch between states makes them ideal candidates for processing information in a quantum manner. In the quantum world, a particle can exist in a superposition of multiple states at once. For example, an electron can be spinning both clockwise and counterclockwise at the same time. The theory proposes that tubulin proteins within microtubules can exhibit similar quantum behavior. They can exist in a quantum superposition of different shapes simultaneously. This enables each microtubule to hold and process a vast amount of information, not just as a simple on or off switch like a computer bit, but as a qubit that holds multiple possibilities at once. This is the orchestrated aspect of the theory. Quantum computations in microtubules are organized by the brain's classical processes, such as the firing of synapses. These classical inputs tune the quantum vibrations, much like a conductor guiding an orchestra. That orchestration links countless quantum computations across the brain into one unified whole, creating a single stream of consciousness. But what turns possibilities into a single, definite reality? This is where Roger Penrose's objective reduction, or OR, comes into play. According to the theory, quantum information in microtubules is not destroyed by objective reduction. It is not even confined to the brain. Encoded in space-time geometry, this information can exist outside the body. This quantum information, a lifetime of experiences and unique essence, is what some might call the soul. The ORCH or theory has sparked a great deal of debate within the scientific community. Supporters highlight its potential to bridge the gap between science and spirituality, physicists and biologists. Critics, however, argue that the brain is simply too warm, wet, and noisy to support the kind of delicate quantum coherence that the theory requires. Despite these criticisms, evidence supporting this perspective is growing. Recent research has shown that quantum effects do play a role in other biological processes, such as photosynthesis in plants. Scientists have also found evidence of quantum vibrations within microtubules themselves. The debate remains far from over, and further experiments are needed to either confirm or refute the key predictions of ORCH-OR. This is the process of science. Bold ideas are proposed, they are tested, and understanding moves forward. Ultimately, the question of whether science can prove or disprove the existence of the soul remains open. Perhaps the soul will always be a matter of personal faith. Or perhaps, as research probes deeper into the mysteries of the brain and the quantum universe, the line between the physical and the spiritual may not be as sharp as once believed. Could the essence of a person be written in the quantum geometry of the cosmos? Could science one day provide a blueprint for the soul? The journey to find out is one of the most exciting adventures in all of science, and it invites everyone to wonder about the deepest nature of reality.